quick video here that has the solutions for 10, 5, numbers 5, 7, and 9. I made another video, and I guess somehow I included all of them except for these. Maybe the reason for that is that College Board has added limit comparison to the curriculum fairly recently. And we calculus teachers are still trying to figure out exactly what their expectations are. The basics of limit comparison are real easy, like the sort of intuition of it, I guess you could say. So if you got something like this, I think that it really it draws on our knowledge of limits, where we look at an expression like this and we think, okay, if we're going to infinity, then the only thing that's going to matter is the highest power on the top and the bottom. And here, this is bigger on the bottom. And if we look at the actual exponents, this is what we're going to say. I'm going to say by the limit comparison test, this series behaves like, you just kind of reduce or divide that out. Not reduce, that's the wrong word. You just simplify this. Coefficients don't matter. Everything that's not the highest power, that doesn't matter. So behaves like this. And what does that do? That converges. Why? Because it's a p-series with p greater than 1. So there's a lot of words you got to say for these problems. Sorry about that. All this is necessary. So how about number 7? 7 5 over 3k is 1. So by limit comparison, this is a little different because it's not a highest power top and bottom. This is like other stuff doesn't matter. Like the plus 1 doesn't matter. And the 5 doesn't matter. So by limit comparison test, this series behaves like, I'm just going to write it as 1 over 3 to the k. And maybe it'll take you a second to just think about that. What's this? You could think about, it's always helpful if you're ever confused with these series to just write out, or at least think of what the first few terms would be. Not necessary to write them out, but if I did write them out, the first one would be 1/3, the second one would be 1/9, and then the third one would be 1 over 27, and then maybe you're like, oh, right, this is a geometric series. So by limit comparison, if this is like this, then that converges because it's a geometric series. And you can't just say it converges because it's a geometric series, because not all geometric series converge. You have to have an r that is in between 1 and -1. So, got to say that. And then, number 9. Back to a p-series comparison here. K equals 1 to infinity. So this all that matters is highest power top and bottom. So by the limit comparison test, this series behaves behaves like, that's just like a k to the 3/2 on the bottom, or 2/3 rather, sorry, 2/3. 1 over k to the 2/3. And what's that do? Well, that's a p-series, and that diverges. Because it's p-series, and the p is less than 1. Right. I guess we could say p is less than or equal to 1, because when the p is 1, it's the harmonic series, and that diverges. So that's all there is to that. And make sure you understand how to say the right words, and not too hard. Definitely draws on our knowledge of limits, which we have.